All right, can we see things? Is this working? What's happening? What's happening? I'm not sure what's happening here. Let me close my journals, I guess. Uh, Sorry to people who are joining. I'm running a little slow today. Oh, now you can see it. Yeah, there we go. Cool. All right. Yeah, I'm a little behind schedule here, but we'll try to start in a second. This is our last stream. Very exciting. Let me remember which one I did last. I thought I just finished up the 20 something, right? Which one did I finish up last? Did I do all of 2017? Yeah, I think so. All right, so 2018 today. Yeah, so 2018. All right, let me pull up 2018, I guess. I'll start with BC. Actually, I'll do AB, I guess. It's more generally helpful. Oops. 18, scoring guidelines. All right, let's get started. All right, this escalator thing, and then we gotta get my calculator up as well, don't I? I have to get my calculator up. Yeah, you can see it now. Awesome. All right, welcome anyone who's watching. Okie dokie. People enter a line for an escalator at a rate modeled by the function r given by whatever, where r is measured in people per second, t is measured in seconds. People get on the escalator, they exit the line at a constant rate of 0.7 people per person per second. There are 20 people in the line at t equals 0. So good to just do things like a of t is the amount of people in line. We know a of 0 is 20. And we know a prime of 0, or a prime of t, I mean, is, well, it's r of t entering and 0.7 exiting, so minus 0.7, so 0.7. Right, good to keep that in mind. And I guess you can just write down what a of t is now. It's 20 plus the integral from 0 to t of a prime of s ds, or of r of s minus 0.7 ds. Right. I do like starting with that just to remind myself of what the actual amount is. This one might seem like a bit much, but it really is just FTC. You might not like the S's, but I need to call it something that's not T, though. So, I don't know. Okay. How many people enter the lines? This is a bit even different. I don't really care about A in this case. That's just going to be the integral from 0 to 300 of R of T at T, because R is the entry rate, nominally. I got to actually dump R into my calculator, so let's do that. Oh my gosh, this is so frustrating. Okay. Go to radians mode, make sure you're in radians mode. I guess it doesn't really matter for this problem, but always check that. 44 and then x over 100 cubed, and then times 1 minus x over 300 to the 7th power. Now you might worry, isn't this piecewise or something? Yeah, but from 0 to 300 it should be okay. So just keep in mind it's from 0 to 300. And then we quit out and we do math 9, 0 to 300. Alpha trace, y1 dx. All right, cool. That's going to be 270. All right, B. During the time interval 0 to 300, there are always people in line. Sure. How many people are in line at 300? 8. This one helped a lot. A of 300 is just 20 plus the integral from 0 to 300 of r of t minus 0.7 dt. Yeah, I think, wait, now you're switching back to t. Yeah, I mean, I would prefer to use t. Here I had to use s. All right, let's just do that one. So that's going to be 20 plus math 9, 0 to 300, 0 to 300 of y minus 0.7 dx. I'm a little concerned about that. If you want to be really careful, you can say like y1 of x minus 0.7 dx. Sometimes it's picky about that kind of thing. 80, I guess. They pick some really nice numbers. All right, for t greater than 300, what is the first time? So after 300, r kind of turns off into 0. So what's the first time there's no people in line? Well, that would be when this 80 kind of depletes. So what's the way to think about it? I want to say in a good way. I mean, I know the way to do it, but I guess you know that. So this function up here is valid on 0 to 300. I guess afterwards, you know, a of t is just 80 plus the integral from 300 to t of just negative 0.7 d whatever ds, because r turns off. I guess technically this equation is valid, but I mean it would happen to equal that one, I guess. All right, and this would equal, and so this would definitely equals just 80 minus 0.7 times t minus 300, and that's supposed to equal 0. I want it to equal 0, so I solve for t. That one's just easy to do by hand. You could graph if you really need to, but you get negative 0.7 times t minus 300 equals negative 80 divided by 0.7. I'll do that in my calculator. 80 over 0.7 is 114. Then you add 300 basically. So you get t minus 300 is something. What was it again? 114.285. 286, I guess. Then you add. So t is 414.286. Great. D, for 0 less than t less than 300, at what time t is the amount of people in a minimum. Minimum means candidates test. So let's find when a prime is 0. A prime of t we know is r of t minus 0.7. You want that to be 0. So that's the same thing as r of t equals 0.7. Let's graph that and solve it. So I got my calculator. We graph a against 0.7. For window, I guess I'm going to go 0 to 300, right? Because that's, well, maybe I'll go a little outside that range. Let's go negative 10 to like 310. And then we want it to be 0.7. I was going to guess it's like, I don't know, 0 to 10. 0 to, oh, maybe 0 to 2. Let's do that. Graph it. We go up. We come down. Great. And then 0.7's there. One of our critical points. First intersection is, well, let's go back here. Oh my gosh, that's one of them. Let's call that A, so X store A. So A now has that point in it. Notice no rounding in the intermediary, which is very good. And then we go back to our graph and we intersect again. And we go all the way over here. Boom, boom, boom. And that's 116.57. So X store B. Oops, store B. All right, we got those two points. So this implies t equals A or B. I would just write those down, I guess. on the actual AP test, I'd write down an approximation for A and B. Cool, and I want minimum. Hopefully I did that right. I feel like I'm a little off here. It's not ringing a bell. But whatever, just make candidates test. So we got 0 and A and B and 300. We know at 300 it's 80. What's 80? A of t is 80. At 0 we know it's 20. We just check the others. So the first one is 20 plus math 9, 0 to, what was it, A? Oops. Oh my gosh. This calculator, like, you'll notice one thing about this calculator, I'm just complain for a second. If I hit a button, like, everything's totally fine. 8, 9, great, great, great. If I hit, like, between 8 and 9, like, here, it, like, sometimes it just, like, shoots my calculator to the other side of the screen, which is extremely frustrating. All right. Alpha trace of y1 dx. Okay, that's the first one, and then I did the other one as well. B. So 26.91, it seems to be correct. What was the one nearest whole number? So I'm going to say 27, I guess. And then the other one was 274.67. I guess I'll record that. All right, let's check my answers. I feel like this is wrong, just based on memory, but I always feel that way, so. I did something horribly wrong. I forgot 0.7, which is really stupid of me, so that is bad. Let me fix that. I totally should remember that. In my calculator, it just integrated R. So let's fix that. These should have both have been minus 0.7, of course. Silly, silly me. All right, so actually it was 3.8. 03. And this one was 158.070. So the answer should not be 27, it should be 4, I think. Let me check that. Hopefully I'm not making another mistake. Yeah, that seems right. All right, cool. And then 414.286, yep, and 80 and 270. Looks good. Okay, silliness there. I just forgot my 0.7. All right, next question. So actually, I couldn't talk about scoring on that one. I think I only lose 1 point on that, actually. It's kind of funny. That'd be 8 out of 9 on that one. All right, number 2. Pulling it up here. More calculator stuff. This again, this is AB, so apologies to any BC people who might be watching at some point. All right, let's see. A particle moves along the x-axis, velocity given by whatever. The particle, let me see if you can actually see my calculator. Well, yeah, you can see my calculator. Okay. Okay. Let's find the acceleration at 3. So that's just A double prime. A double prime. Oh my gosh. V prime, which is X double prime. Acceleration of the particle, that's just V prime of 3. Let me do it in black here. So dump V into my calculator. Make sure you are in radians mode here. I already checked, but okay. 10 sine of 0.4 t squared. X squared's fine. And then over, make sure there's parens here. X squared minus x minus 3. X plus 3, I mean. All right, and then acceleration, that's just the derivative. So that's math 9, math 8, I mean, ddx of y1 at 3. All right, negative 2.118. All right, find the position at 3. Well, that's easy. That's going to be x of 3 minus x of 0 is the integral from 0 to 3 of v of t dt, because x prime is v. And that's going to be x of 3 is x of 0 is -5. So that's going to be -5 plus that integral. So I'm going to say, well, I guess I should say, this implies x of 3 equals -5 plus the integral from 0 to 3 of v dt. And that equals, got my calculator, -5 plus math 9, 0 to 3, alpha trace y1 dx, and that should be good. -1.76 is cool. Minus the decimal. -60. Right. C, evaluate that integral and evaluate that integral. Okay, that's super easy. Math 9, 0 to 3.5. Alpha trace y1 dx. That's the answer to the first one, and need an absolute value here, so math num abs of alpha trace y1 dx, and there you go. I'll just screenshot those because I'm lazy. Once it does it, oh my gosh, it's so slow on the absolute values. All right, those are my two answers there. I'll just box the correct one. So that one is, I would call that 4, I guess. I like to round. And this one would be this one, which is that. Okay. Interpret the meaning. The first one is a displacement. Oh, I'll type it out. First one's a displacement. I'll move this down to a legible place. The second is the total distance traveled, TDT. Oh my, I cannot type today. Oh my gosh. Cool. Looks good. Oops. That's for C. All right, D, a second particle moves given by whatever. When are they moving with the same velocity? Okay, so I want to know when x2 prime of t is v of t. I guess I just graph that, huh? So what's x2 prime? X2 prime of t. Very rare you do this. You actually, on a calculator section, have to differentiate by hand. You might be able to do it in a way, but this is really easy and it seems correct. So 2t minus 1. And then I'll go to my calculator and dump that in as y2. And just graph both of them. Let's go zoom 9 on the, or I guess, what's the window going to be? It's going to be 0 to 5 or something. And then the y min seems to be bounded by, I don't know, I'm going to guess like 20. Who knows? Maybe like -20 to 20. Might be too much. Let's see. Not horrible. Yeah, I want to zoom in a little bit, huh? Let's just do this a little better. Let's go -5 to 10. That seems better. There's my first one. That's our original velocity. And the second one is going to be given by that. And I guess you want the intersections there. So second calc intersect. Up. And 1.570. So I'll say x2 prime of t equals v of t implies t equals 1.570. 571 technically. All right. Checking my answers. Let's see. 1.570 looks good. First one is 2.844. Yep, and then 3.73. Yep, looks good. Displacement, total distance traveled. Yep, and then the position is -1.760. Yep, and the -2.118 looks good. All right. On to non-calculator. All right, how are we doing on time? I started at 05 or 06 or something, and I was taken 4, 10, 14, 15, 16 minutes. Okay, I'm going to double speed. Let's do the next one. They're not very hard when you know what to do, I'll tell you that. Um, well, aside from making silly mistakes, I do that a lot. Where am I? I can never find the darn document. Okay, I should turn off my calculator. Right. The graph of the continuous function g. Let me just a little smaller, huh? That's probably better. Okay, the graph of the continuous function g, the derivative of the function f. It's kind of a weird thing to say. I don't like that, but f prime is g. They just said that. Shown above the function g is piecewise linear. Cool. And then there's a quadratic. If f of 1 is 3, is this 2018? I feel like I've done this so many times. I guess it is. All right. If f of 1 is 3, what's the value of f of negative 5? Okay, that's just going to be some FTC thing. So we know a lot about g, which is f prime, so probably FTC. So f of 1 minus f of negative 5 is the integral from negative 5 to 1 of f prime, or g of t dt, right? G is f prime. F of 1 is 3, so 3 minus f of negative 5 is negative 5 to 1. That's this area. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10, and then, so I'm going to mark this in. This has an area of 9. This has an area of 1.5. It's negative, of course. This has an area of 1. This has an area of 2. And then the quadratic's more complicated. But this would be 9, so 9, 10.5, negative 10.5 plus 1, negative 9.5. And that's going to be, take away 3 from both sides, over here. Negative f of negative 5 is negative 12.5. Look, I did this wrong. I can double check my answers. F of negative 5 is 12.5. That seems totally wrong, I think. You pick up 9, pick up 10.5, 9.5, and you get to 3. Maybe that is right. All right, I do like them as a fractions, though. 25 over 2. Okay, that's A. I'll do B down here. B, evaluate the integral 1 to 6. This one's trickier because you have this quadratic involved. Right? You want to find the area under the curve, but how do you find this curved part? That's really tricky. Well, I mean, it's not that tricky. You did the integral from 1 to 3 first, because that one you can do just normally. And then you add on 3 to 6. The first one is just 2, which is convenient. And on the second one, g of x happens to equal this quadratic. 2 times x minus 4 squared. This is a weird one. If you expand this and try to do it by hand, it's kind of a pain in the butt. Like, the numbers get really large and they kind of cancel out something cool. Here, you should actually u sub for convenience. I would u sub in u is x minus 4, and I would get 2 plus the integral from negative 1 to 2 of 2u squared. That's with u is x minus 4. And this one's actually a lot easier to do. This is 2 plus 2 integral negative 1 to 2 of u squared. Well, I guess it's 2/3 u cubed, right, from negative 1 to 2. And that's 2 plus, make sure this is in parentheses there, 2 plus 2/3 times 8 minus 2/3 times, did I do this right? Yeah, I did, okay. 2/3 times negative 1. And that's 2 plus 16 over 3 plus 2/3, which is 2 plus 18 over 3, which is 2 plus 6, which is 8. All right, C. For negative 5 less than 6, when is f both increasing and concave up? So f is increasing when f prime, which is g, is positive. And then f is concave up, so smiling, when f prime equals g is increasing. So I want g to be positive and g to be increasing. Let's look. Well, g is increasing here, here, and here, and it's positive only on the right. So 0 to 1 and 4 to 6, or something like that. Yep, 0 to 1 and 4 to 6. I'd say this is where g prime is, the justification would be, this is where g prime is positive and increasing. G prime. G is positive and g is increasing. Looks good. All right, D. Find the x-coordinate of each point of inflection. Well, F has a point of inflection, means F changes concavity. It's the same thing as F changes concavity. And that's the same thing as F del prime changing sign. I want it in terms of F prime, though, because that's what I can look at. This is when F prime changes direction. So increasing, decreasing, or whatever. And F prime is G. So I want to know when G changes direction. That's the same thing. G changes direction. This is kind of confusing. Let me erase this stuff. Well, definitely at 4, right? Because they're going decreasing to increasing. And that's it, right? I mean, you kind of want to say it's like somewhere in the middle from 1 to 3, but no, it's flat there, which doesn't count. So just 4. Which occurs only at x equals 4. And this actually would be good enough justification, I think. All right, let me check my answers. Fingers crossed. 4, yep. 0 to 1, 4 to 6, yep. Oh, did they say open intervals? Should I have been careful about that? Yeah, they did say open intervals. I should have mentioned that. I, by habit, did pick open intervals, but they almost always want open intervals. Oh, I did this one wrong somehow. H number 3 is 6, right? This is area 2, didn't I? Oh boy, you know. These 2s are all 4s, aren't they? Gosh, very, very silly. There you go. That's what happens when you go fast, or are absent-minded. And 25 or 2 is correct. Let me see. Split at 3. Yep. Antiderivative. Yep. So I still would have gotten 2 out of 3 points on the B, even though I was being really stupid and said that the first one was 2. All right. So I would get 8 out of 9 on that one, I think. All right. Next one. Number 4. The height of a tree at time t is given by a twice differential function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. Use the data in the table to estimate h prime is 6. Okay, they just want average rate of change on this interval, basically, because 6 is in the middle. That's the idea. So h prime of 6 is approximately h of 7 minus h of 5 over 7 minus 5, which is equal to 11 minus 6 over 7 minus 5, which are 2, I guess, which is 5 halves. Cool. And and then it wants an interpretation. I'll write that up here. I'll write that down here, I guess. Oh, fine. So here's A, and the interpretation is going to be the following. So h was the actual height, right? So at time, what was it? Time is in years. At 6 years, whatever, at t equals 6 years, the tree is growing. You don't want to say like increasing, decreasing, growing is fine. Growing at a rate, or don't want to say growing at a rate, growing at approximately, this was an approximation, of course, approximately 5 halves meters per year. Does that look good? Yep. Yeah, and meters per year is the right one. Because it's like h over t, kind of. All right, explain why there must be at least one time t. That's got to be EVT or IVT or MVT. So I will write my little word here. So where h prime, oh, this one, I do remember this one. This one is disgusting. So this is a real jerk move. So the problem is they tell you 2 to 10, and you're like, okay, great, I'll do that. MVT, like, I know h, I'm trying to find h prime, that's MVT. Let's check, let's write down why it actually satisfies MVT first. So h satisfies MVT, or the hypothesis MVT, well, on what interval? I guess 2 to 10, right? Because h is differentiable, right? Twice differentiable. And then I might just say, and thus differentiable and thus continuous everywhere. All right, cool. So that satisfies hypotheses. And now, okay, the real jerk move is you're like, okay, it tells me there's a time when h prime of c, right, equals h of 10 minus h of 2 over 10 minus 2. You do that and you get, what is it? 15 minus 1.5. Maybe thinking, wait, it's supposed to be 2. That's kind of issue. That's kind of issue, huh? 15 minus 1.5 is 13.5 over 8. And that's not 2. What gives? Well, the real thing is they're being a jerk, and you're not actually supposed to do this interval. You need to check every single every single sub-interval you can from the table. And I believe the magic one is 3 to 5. Isn't that awful? 6 minus 2 is 4 over 2. Yeah, 2. It will work there. So really what you need to do is not say 2 to 10 here. You got to say 3 to 5 because h is twice differentiable. And then by MVT, you get... by MVT, there is a time t is an element of 3 to 5 such that h prime of t is h of 5 minus h of 3 over 5 minus 3, which is 6 minus 4 over 2. Is that what it was? Yeah, 6 minus 2 over 5 minus 3. 6 minus 2 over 2, which is... oh, that's the wrong one. No, I'm just not thinking. Okay, yeah, is 4 over 2, which is 2. There we go. Yeah, okay. And then you might say, it's kind of silly, but since t is in 3 to 5, t is in, what was it again? They wanted 10. 2 less than t less than 10. You don't need to say that. So you just have to check every single one, right? So you need to check 2 and 5, 2 and 7, 2 and 10, 3 and 5, 3 and 7, 3 and 10, 5 and 7, 5 and 10, 7 and 10. And just cross your fingers it doesn't take you too long to figure out the one interval they had in mind. That's really frustrating. It's kind of funny though. I kind of like that problem in a twisted way. All right. Let's see. Next one. Use a trapezoidal sum without a calculator, which is really dumb of them, especially since it's not equally spaced, which is really annoying. Okay, we'll do that though. Approximate the average height of the tree. So careful, average height, that's 1 over 8. So h average is 1 over 8 times the integral from 2 to 10. Is that what it is? 2 to 10? Okay, 2 to 10 of h of t dt. And that's going to be approximately 1/8 times Gaudian trapezoid rule, which is super fun. I promise. It's 2 plus 1.5 over 2 times 1, and then plus... You know, sometimes I actually want to see this, which I really don't like. They want to see... So 2, 3, 5, 7, 10. I got to remember that. 2, 3, 5, 7, 10. You can say this. This is like what the answer key will say, I believe. H of 2 plus H of 3 over 2 times 3 minus 2 minus 2 plus H of 3 plus H of 5 over 2 times 5 minus 3 plus da, 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 da. I'm not going to write it out, but they want to see something like that. I mean, they probably are okay with saying other things, but I believe the answer key does literally say that. And then that would be equal to 1/8 times, I just should copy this down, 1.52, I should just copy this. 1/8 times, what is it? 1.5 plus 2, so 1.7, God, I really hate that. 1.75 times 1, huh? And then the next one is average of 2 and 6 is 4, so 4 times 2 is 8. And then average of 6 and 11 is 17 over 2, which is 8.5, so 8.5 times 3. And then plus average of 11 and 15 is 13. 13 times 3. Just double checking this what they want. Man, non-calculator on this is just rough. Gosh, I hate when they do that. Fine. And then that's 1/8 times, I guess 8.5 times 3 is 24, 25.5, huh? 1.75 plus 8 plus 25.5 plus 13 times 3 is 39. So let me add the integer parts. 1, 8, 25, 39. 1 plus 9, 10, 18, 23. And then 2, 2, 4, 7. So 73, and then 0.75 plus 5.5 is 1.25, so it's actually 74.25, I believe. And then you divide by 8. This can't be right. I must have done something wrong. 74.25 over 8, which is, well, I'll give a fraction just to be annoying. So 74.25 times 4 is 2, 0, 10, 16, or 17, 29, so 297 over 6 over 32. I really need to make sure that's correct. So let's just check. 297 over 4, 714.25. Yep, that's right. And then divide by 8. Man, 297 over 32. What a ridiculous problem. And I probably made a mistake. I'm going to check that one right now just to confirm. Yeah, I'm off by a little bit. Isn't that wonderful? It's actually 263 over 32. What did I do wrong? I would probably get 1 point for that. That's an awful, awful, awful question. I hate that so much. So many places to make a mistake. Oh, let's double check what I did wrong. 2.5, 2.5, 4. 4 times 2 is 8. Come on, 7 minus 5 is 2, not 3, huh? That'll do it. So not 25.5. That's a 2. So 16.17 actually. That's actually a bit nicer, huh? And then after this all is garbage now, erase that. Now you add these all together, and it would be 39, 17, 8, and 1. And that's 10, 18, 25, and 65. And then 65.75 times 4. So that's this whole thing is 65.75. Hopefully I'm being clear about that. And then I want to get it as a fraction. So I multiply by 4 because definitely this is by 4. 20 and then 28, so 30, and then 4 times 5 is 23, and then 4 times 6, 24, 243, 283. Still goofing up. 4 times 6 is 24, 26. Oh my gosh, 263. There you go. 263 over 4 over 8, and that's 263 over 32. Whatever. I'm not unhappy about getting that one wrong. It's just a dumb question. All right. I really, really think they shouldn't do trapezoid rule with unbalanced things and decimals by hand. It's just very frustrating. Okay. D. And again, it's only 1 point off to goof that up. The height of, I should just copy this because I'm not going to scroll up a million times. The height of a tree in meters can also be modeled by whatever. Usually when they say that, you don't need to use anything in the previous parts of the problem. So where x is the diameter of the base in tree meter is fine when the tree is 50 meters tall. Tree 50 meters tall, that means g of x is 50, huh? So what would the diameter be? 100x over 1 plus x, you can solve that. That's 50 plus 50x is 100x. I think x is 1. 50 is 50x, so x is 1. Cool. So the diameter is 1. That's important. The diameter of the base of the tree is increasing at that much. So dx dt is 0.03. According to this model, what is the rate to change the height of the tree? So they want dg dt or whatever, which is really annoying. I mean, yeah, this is one of these things. Just they say it in terms of x and they want it in terms of t. It's always frustrating. But dg dt should be g prime of x times dx dt. That's the idea by chain rule. That's kind of like related rates. And we know x is 1. That's convenient. We know dx dt. What's g prime of 1? I got to compute that. G prime of x is low d high minus high d low over low squared. like that. And that's 100 plus 100x minus 100x over 1 plus x squared. And that's just 100 over 1 plus x squared. So g prime of 1 would be 1 plus x in paren squared. G prime of 1 is 100 over 1 plus 1 squared, which is 4, so 4, and then that's going to be 25. So g prime of 1 is 25. So here dg dt at x equals 1 is going to, or at g is 50 or whatever it was, is going to equal 25 times 0.03, which is decimal goes over twice, and that's going to be 0.75, which is 3/4, which I'm pretty sure that's the correct answer. I think I remember that one. Let me check all these. 3/4, yep, that one's annoying. Yeah, you pick 5 and 3 for that one. And then 5/2, yeah. All right. That's a really awful problem, I feel like. This is mean, mean, mean. B is mean, C is mean, D is actually pretty tricky, I think. All right, next one. Number 5. Let f be the function defined by f of x equals e to the x cosine x on the average rate of change on 0 to pi. Well, that's pretty easy. That's going to be f of pi minus f of 0 over pi minus 0. And that's going to be e to the pi cosine pi minus e to the 0 cosine 0 over pi. And that's going to be, cosine pi is -1, so that's negative e to the pi, cosine 0 is 1, e to the 0 is 1. So negative, so like that, right, over pi. You can call that -1 over, you can call it something, negative e to the pi plus 1 over pi. Great. Does that make sense to me? Yeah, it should be decreasing. Okay, and then that's A. I'll do B down here. What is the slope of the line tangent to the graph at 3 pi over 2? Okay, so you just want f of 3 pi over 2 and f prime of 3 pi over 2. Every time you get a tangent line, that's what you should do. F of 3 pi over 2 is e to the 3 pi over 2 cosine 3 pi over 2, which is 0. And then, because cosine 3 pi over 2 is 0, of course. And then f prime of 3 pi over 2, well, I got to find f prime of x, I guess. Product rule, huh? So e to the x cosine x minus sine of x e to the x. And that's going to be, f prime of x is going to be, f prime of 3 halves pi is e to the 3 pi over 2 times cosine 3 pi over 2, which is 0, minus sine of 3 pi over 2, e to 3 pi over 2. That's 0 minus, sine of 3 pi over 2 is -1, so 0 minus -1 times e to 3 pi over 2. So e to 3 pi over 2. Great, so I got my point is 3 pi over 2 comma 0. And I go, that's the point, and the slope is e to 3 pi over 2. And now it takes about a second to write down what it is. L of x is e to the 3 pi over 2 times x minus 3 pi over 2. Cool. Hopefully that's right. And then C, what's the absolute min on 0 to pi? That's going to be a candidate's test or something. So got to find the critical points. We have f prime conveniently. I need to add another page, don't I? So when is 0, f prime of x equals 0 is the exact same thing as e to the x cosine of x minus sine of x e to the x equals 0. And that's when e to the x cosine of x equals sine of x e to the x. The e to the x's are always positive, so you can cancel them. You want cosine equals sine, you divide by cosine. 1 is tangent of x. That's going to be on pi over 4. So x is pi over 4 or 5 pi over 4. All right, and so the critical points, it is 0 to 2 pi, right? So I got to check my, got to check 0, pi over 4, 5 pi over 4, and 2 pi. Now, you can actually use a sign diagram here that may be useful. We'll just see. Got to plug these in. What's f of 0? Well, f of 0 is, I think we just figured out was 1, right? Yeah, we knew that over here. It was 1. F of 2 pi is going to also be, well, is going to be e to the 2 pi. So I should say that. So I'll hold off, I guess. So f of pi over 4 is e to the pi over 4 times cosine pi over 4. And that's equal to e to the pi over 4 times root 2 over 2. Don't worry about how awful it looks. Oftentimes it only matters if it's positive or something. And then f of 5 pi over 4 is e to the 5 pi over 4 times cosine of 5 pi over 4, which is negative e to the 5 pi over 4 times root 2 over 2. And then f of 2 pi is going to be e to the 2 pi times cosine 2 pi, which is just e to the 2 pi. And they want the absolute minimum value. So the only one that's negative will be it. So it'll be at 5 pi over 4, comma, e to the negative 5 pi over 4 root 2 over 2. That's my answer. All right, D, let G be differentiable such that G of pi over 2, I should just copy this one down because I don't want to scroll up a whole bunch. I do apologize, I need to copy a little bit extra. All right, D is shown below. We want the limit as you go to pi over 2 of f of x over g of x. That's really cool. Probably L'Hopital's rule. So you need to do stuff. It's actually kind of annoying. You got to do the limit as x goes to pi over 2 of f of x. Well, that's continuous. F is continuous. That's just f of pi over 2, which I think we saw is going to be 0. I guess it's e to the pi over 2 cosine pi over 2, right? Is 0. And then the limit as x goes to pi over 2. You do need to write down these limits, otherwise L'Hopital's is not justified. G of x is, well, g over pi, it's differentiable, so it's continuous. I'll just say g continuous because it's differentiable. It is just g of pi over 2, and that's 0. Cool. So it's 0 over 0, so I can use L'Hopital's. So the limit as x goes to pi over 2 of f of x over g of x is the limit as x goes to pi over 2 of f prime of x over g prime of x. And here, I think it's fine. G prime is obviously continuous because it's shown down here. And so this is going to be f prime of pi over 2 over g prime pi over 2. You do need to know that f prime is actually continuous there, but it is. I mean, f prime is continuous. And f prime of pi over 2 is, what is that going to be? That's going to be, I'm a little queasy. Gosh. What was f prime again? Ex cosine x minus ex sine x. Okay. E to the pi over 2 cosine pi over 2 minus e to the pi over 2 sine pi over 2. And that's going to be negative e to the pi over 2. Because that guy's 0 and this guy is negative e to the pi over 2. So negative e to the pi over 2 over, it looks like 2, right? I guess that's it. Negative a half e to the pi over 2. I have no idea if any of these answers are right. Let's just check. I got C right. I got D right. I got 3 pi over 2. Did I? Oh, I just B wants just a slope. Oops, that's stupid on me. Well, it's just that. Okay. And then I don't know if I guess I get the point for that because I did write down the slope and f prime. So, and negative e. Yeah, that was right. Okay. Always read the questions. I'm going too fast today. Got one more. I'm not going to do BC today, I don't think. Consider the differential equation, whatever, A slope field given, sketch the solution. I feel like they don't have you do that very much anymore, but maybe I'm wrong about that. Goes through 1, 0. Oh, wait, two of them. Sketch the solution curves that go through 0, 2. So that looks like this. And 1, 0. Just draw it so it never crosshatches. It's really easy. Cool. Like that or something. Let f be the particular solution at 1, 0. Write an equation for the line tangent. Okay, well that's, again, you just need to do, I'll just say b over here. You just need f of 0 or f of 1 and f prime of 1. F of 1 they tell you is 0. F prime of 1, well, you use a dy dx formula. So that's going to be like dy dx at 1, which is 1/3 times 1 times what's y? Y is 0. 0 minus 2 squared. And that's 4/3. Yep. So I get the tangent line is L of x equals 4/3 times x minus 1. Cool. C, find a particular solution. I guess I want more space for that. So with f1 equals 0, huh? And let me just grab this differential equation again. That's the DPQ I'm working with. All right, just kind of relaxed separation of variables, huh? dy over y minus 2 squared equals 1/3 x dx. Oh my gosh, I'm going to sneeze. A third x dx. And you integrate, and this one turns into the 1 over 6x squared plus c. And this one turns into something a little annoying. I think it's negative 1 over y minus 2. If I differentiate that, what do I get? Differentiate, I get the negative 1 comes down. Yeah, that seems right. All right, and we solve for y, so it makes everything negative. 1 over y minus 2 is negative a 6x squared plus c. Again, you don't need to worry about plus c because negative c is just different constant. Flip everything. Y minus 2 is 1 over negative 1/6x squared plus c. And then add 2 to both sides, so y is 2 plus 1 over negative 1/6x squared plus c. Let's make things a little tidier. Let's just multiply the bottom through by negative 6, or the bottom and top of the fraction through by negative 6, so 2 minus 6 over x squared plus c. Again, negative 6 times c is just c, so this looks nice. Am I doing that right? Seems reasonable. And then f of 1 is 0, so plug in 1, 0, and you get 0 is 2 minus 6 over 1 squared plus c. So we get 6 over 1 plus c is 2, and so we get flip everything. 1 plus c over 6 is a half, multiplied by 6. 1 plus c is 3, and then c is 2. So it looks like it'll just be, if I edit this one, y is 2 minus 6 over x squared plus 2. And we just think about that. If I plug in 1, I get 6 over 3. Yeah, it gives me 0. And if I differentiate, I get probably the right thing. So I'm going to call that good. And let's check my answers. What is it? Looks great. And then we get negative 0.4. Oh, I completely didn't read part of it. Oh my gosh, I'm really not with it today. I guess I would take a point off for that because it does say to use the equation to approximate f of 0.7, duh. So I should have done f of 0.7 is approximately L of 0.7, which is 4/3 times 0.7 minus 1, which is 4/3 times 0.3, which is 4 times 0.1, which is 0.4. And it's negative 0.3, silly me. So negative 0.4. Oops. Did I get it right? Yes. Yes. Okay. And a lot of errors today. I'm blazing through it, so there you go. That's 6 questions in an hour about maybe more like 50 minutes. You should go slower on your tests, of course. I think I'll stop there. Well, thanks to anybody who is watching. I hope this is helpful or studying for your calc test. I know it's on Monday, and this is the last stream, and so good luck to you out there who are trying to get a 5 in the calc test. Have a good one.